Hello, I'm actually, my name is Chima Duru, and I'll be presenting today the topic agentic systems in practice. So we're actually going to be talking about the agentic systems in practice, and we are going to be looking at what it takes to build autonomous AI workflows. So let me start with a simple comparison. About a year ago, we asked AI to answer questions. That's basically what we started with AI to basically ask questions. And right now, people are now going further than just asking questions and chatting to now request that AI helps them to investigate issues, investigate incidents, fix pipelines, developers, and generate and deploy code. And increasingly, we are not just asking it to just respond to those queries, but right now we are asking it to decide what to do next. So this shift from response to action is what is actually defining the agentic systems. So today would break down what agentic systems means in practice and how to build these systems safely. So why agentic systems matters? So traditional AI has always been reactive, and then when you send a prompt, you get a response. But agentic systems are different; they are proactive. So they take a goal and figure it out how to achieve it. So you give it a goal and it figures how to achieve it. And it's powerful because it automates multi-step workflows and reduce manual interventions. And it also enables continuous operations. So think of it as moving from AI as a tool to AI as a worker. So there's that shift from passive AI to now active AI, and you're enabling a continuous decision making system. So it's not just that you give it a particular request and it gives a feedback. No, so it's more of a loop or decision making system based on what has been decided previously. So it's making decisions, almost like how the way humans operate. Yeah. So what is an agentic system? An agentic system has four core capabilities. It can perceive inputs. It can reason about what to do. It can act using tools, and it can learn from outcomes. So that is basically the key idea is that is we're not just building endpoints, but we are building systems that make decisions over time. So this is one of the most important mindset shifts. So we are actually moving from just basic prompting to now a workflow. So traditional AI is just one output, one input, and you obviously get one output. There's one single prompt gets a single response. Why agentic AI is more like one goal that can be set will give so many steps. So it might plan, call APIs, evaluate results, or adjust strategy. So instead of thinking in requests, we actually need to think in workflows. There's that iteration of workflows. There's that iteration. So the next one, we'll be looking at the core components in the section one. We'll be looking at the core components, and in the core components, we'll now be looking at the agent architecture overview. An agent is made up of a few building blocks. The first is the reasoning engine, which is usually the LLM. the LLM. And the next one is the memory, which might be either short term or long term. So it can remember a context. So there's always a context to which the AI is actually making those decisions. And then the tools, which might be APIs, systems, anything it can interact with. Then there's a planner. It decides what to do next. And finally, there's a cushion loop. So the important thing here is that an agent is not a single function. It is a system of all these that we made mention of: the LLM, the memory, the tools, the planner, and then the execution loop. So we'll be looking at the agent loop. So the agent loop is more like this loop is the heart of the agentic systems. So it's actually goes like this: that it's the system receives a goal, then receiving a goal, it now decides on the next action. It plans the next step. Then after that, it executes it, observes the results, updates the context, and then there's a repeat, there's a cycle. So this loop continues until the task is complete. And this is what gives the system autonomy. And then this also can go wrong if it is not controlled. It can go wrong. And yeah, so we'll be looking at the types of memory. Just like I mentioned earlier, there's a short-term memory, there's a long-term memory, there's an external state. So agents actually need memory to function effectively. And there are three types of memories, which is the short-term memory, which most times saves the current task context. It keeps the current task context. When the long-term memory is most times used for the stored knowledge, or often in vector databases. Then external state, it actually acts as a more like logs, database, and API. So without memory, agents would actually behave more like a goldfish, more like someone that has a memory, someone that you actually meet, and then the person can't remember the person's name, or the person can't. Yeah, so that's obviously how, because there's no system to store the knowledge that has been gained over time. So that's and there's not going to be context to the next level of output that the AI engine is actually going to present. So we are going to be looking at tools, and then tools and integrations. Tools are what allow agents to act. So without tools, an agent is just thinking. Yeah. So with tools, it can query databases, it can trigger pipelines, it can update systems. So in practice, tools define the power and the risks of your agent. So just like you can see the APIs, databases, CI/CD pipelines, CI/CD pipelines, the monitoring systems, and the file systems. So we are going to be looking at in the section 2, building workflows. So we are actually going to look at building these workflows. How do we go about building this workflow? So there's a workflow pattern, and there are several ways to design agentic agent systems. So most times the best way on how to start is to start simple. You build a single agent loop that actually gives out a one agent doing everything. Yeah, so it starts, maybe you can actually start with a planner plus executor separation, or the multi-agent collaboration, and then there's that human in the loop for a control. Yeah, so most times it's best not to start with multi-agent systems because they add complexity quickly. As much as possible, that single agent system should be more like what engineers should look at setting up before then you understand the workflow, understand how it works before the multi-agent collaboration can be put into place. So let's have an example of a DevOps incident agent in practice. So let's just try to make this real. Imagine an agent is actually handling incidents. This agent can actually detect alerts. Once it detects the alerts, it analyzes all the logs and metrics, and it identifies root causes. And with these root causes, it can now suggest fixes, and then execute remediation for those fixes that it's actually suggested. Yeah. So actually, in fact, one of my colleagues, we actually working on exactly this kind of agent workflow, and then yeah, we submitted that in the Microsoft recent hackathon. We submitted that in the hackathon, and yeah, so most times this is where DevOps is a natural fit to agentic AI, is how agentic AI can help the DevOps workflows. The next one is how can we design agent workflows? So most times the advice is a good agent design is very critical. If that design is not put into place correctly, then you're obviously going to get some issues. So what are the key principles? The key principles is to first define clear goals as much as possible, limit what actions the agents can take as much as possible, ensure observability, and they build a fail-safe mechanism, and then keep actions idempotent. So bad designs usually leads to unpredictable behavior, which is very bad when you have AI agents set up. Anything that has to do with AI, it should be able to be predictable. That should be the goal. Then the human in the loop. Autonomy doesn't mean removing humans. So if you're building an agent, if you're building an AI system, it's definitely not going to remove the human in the loop. Humans actually augment, and it's not like humans are kept one side. So should define. So the human in the loop should be considered. So there should be approval checkpoints, escalation triggers, and confidence thresholds. The goal is to ensure that there's controlled autonomy and not just blind automation. Yeah, so the section 3 will be looking at the architecture. What does the agentic system architecture look like? So at a high level, you have a trigger. That's a user trigger, maybe from a user or a system, then an orchestrator coordinating everything, then the LLM and the planner. Then you now have the tools and memory, then the feedback loops, and the orchestrator is actually key because it controls execution and safety. Yeah, so in terms of observability and monitoring, you must monitor the areas that, in terms of the agentic systems, the areas that we actually need to monitor is what decisions the agent makes. That monitoring should be there. What decision does the agent make, and what tools it calls, and how long it takes, and where it actually fails, and how much it costs. So because if it cannot be observed, then the system cannot be trusted. So like I mentioned earlier, there should be that control. There should be that control of the system, and then everything should be able to be predictable. And yeah, we look at the cost considerations. Agentic systems cannot become expensive fast. So the reason why is that multiple iterations can actually make agentic systems become very expensive. So if there are multiple iterations, recursive loops, and repeated tool calls, obviously the cost of the agentic systems is going to be so expensive. So how do we try to mitigate and try to prevent a costly system if we intend to build one? the mitigation strategies majorly is around, you must limit loops as much as possible, try to cut down on loops, and set a budget, so you actually are able to like control and understand expectations, set budgets, and cache the results, and then scope tasks tightly. Yeah, so we'll now be looking at risks and governance. The risks and governance of in agentic systems. Obviously, for anything, there's actually pros and cons, and then we're looking at the risks. And when we look at the risks, we now look at, okay, with this risks, how can we govern? How can we try to put things in place in terms of governance to control this risk? Agents actually simplify both power and risk. So the key risk is actually uncontrolled actions and infinite loops, and then hallucinated decisions. Because once there's no control to, because agents, AI systems, most times the more the decision it makes, the more it derails. So that's derailing. That shift should actually be measured to know where it's now beyond the scope of the allowed scope. And the data leaks, these are the real risks of agentic systems. So the more autonomy that you actually give to the system, the more needs you actually need to be able to control it. That is very key. And so how do we now govern agents? That's a key question I know most of us will be asking right now. How do we govern agents? So to manage this, we must define, just like I mentioned earlier, we must define action allow lists, and then implement rate limits, and also log everything as much as possible. And firstly, we must try to run this in sandbox environments, because governance must be embedded and not optional. It must be put in place and not optional. And the security considerations that we must put in place must be, we must ensure that security is critical, and we must protect against prompt injection, because this is one of the key areas where the agentic systems can go wrong. If there's a prompt injection into the system, then the system is going to be corrupted, and once the system is corrupted, obviously we are going to be getting a lot of infiltrations. So an unauthorized tool access should have also be put in place. So this protection should be put in place, and then sensitive data exposure. As much as possible, for some organizations, that maybe the data loss prevention policy should actually be set up to ensure that sensitive data are being classified. So if sensitive data are being classified, if this data is being managed wrongly by the system or being used by the system, then there's always going to be a flag. Once that flag is there, then we could the engineers can jump in immediately and try to get everything sorted out. So most times it's advisable that before the systems are built up, AI systems are being put in place, that the data of the organization is well structured and well managed with regards to classification and regards to management. So everyone actually everyone's data and the sensitive data is being kept in line with the compliance regulations, because agents can actually expand attack surface significantly. That could be something that could spike the rate of attack surface. So let's look at real world use cases for agents. So most times, real world use cases, agents can actually be used in DevOps automations, or maybe support workflows. We can actually in some enterprises, they can actually use that for support workflows, or use that for the data pipelines to manage the data pipelines, or maybe codes generation. Yeah, some organizations, I know some organizations that use this for code generation and also for incident responses. So maybe it's just to think of how can you use agents within your system? How can you use agents within your system to maximize the value that agents actually have to bring? Just try to think about this when you look at the real world use cases that I'm actually showing right now. Just try to think in what way can I use agents within my agentic systems? In what way can I employ agentic systems within my environment? Yeah, is a critical thing to think about. So most times, anywhere that you have multi-step workflows, it is really very critical to have the agentic systems and then being set up. So where does agents work best? We need to know where they work best so we can employ them in those areas. Just like someone you're trying to employ, you need to understand what's the person's CV. How will this person be impactful to my organization? How will this person give me the best value for the money that I'm actually investing in this individual? So just like agents, we are employing them. Obviously, are going to be employed, and then we need to understand how they can actually work best for us. And most times, agents work best when the tasks are multi-step and when decisions are repeatable and when context is rich. If the context is very rich, then yeah. And when there's actually cross-system orchestration. So for agents, just avoid simple tasks and then avoid high-risk decisions without control. Yeah, we cannot entrust high-risk decisions without control to agents to help us to do that. We the humans actually need to be the one involved in that. So the agentic, let's look at maturity. The agentic maturity model that is normally being put in place. How can we set up that maturity model? So it evolves in stages. Agentic systems evolve in stages. So most starts from prompt-based automation, then to augmented systems, then single agent workflows. Then it now goes to the multi-agent orchestration, and then finally the point of full maturity is the fully autonomous systems, which is what we are talking about. So maturity must be intentional from the point-based automation down to the fully autonomous systems. It should be very intentional. And the adoption strategy should, as much as possible, start with narrow use cases, clear return ROIs, that's return on investment, and human oversight. There should be that human oversight. Then you can then expand to increase autonomy and maybe then expand the level of tools that is being used, and then improve reasoning. So there's a journey and not just a jump. There should be that journey from where you actually just narrow use cases, clear the return, ensure that return on investment is clear, and then there should be that human oversight, looking after over things, trying to iterate and streamline the process. Then, yeah, that should be the right strategy on how to adopt agentic systems. I know some of us might be trying to understand, okay, how within my organization, how can we try to adopt AI agentic systems within my environment? This should be the best way on how to approach that. So that should be it. That should basically be it. So the key takeaway is that I think we should be looking at when we are thinking about agentic systems is that agentic systems act and they don't just respond. So, and also agentic systems operate in loops. just like I mentioned earlier, there should always be that if there are multiple workflows, then obviously agentic systems will come into place. And then agentic systems rely on tools and memories. So that should be key considerations when employing agentic systems. And then require strong governance, because if those governance are not put in place, then obviously you're just building catastrophe and in your organization. Yeah. So then the next one should be that you should, as much as possible, agentic systems deliver value in complex workflows. So yeah, so most times the value is realized where the system is actually set up properly. So there's that value in complex workflows and multiple systems and multiple workflows. That is where you get the best value for agentic systems and not just simple workflows. So agentic AI is not just a smarter software. It is a software that can decide and act. Yeah, so why not explore that, and why not use that, and employ engineers as much as possible, try to get into it and see how to use these tools to help organizations get better, because this is where organizations are willing to pay more for at the current state. Yeah, those are my key takeaways. And yeah, so I would just say that as much as possible is best to act fast, and act safely while using agentic AI, and ensure that the right processes and procedures are being put into place. So I'll be, if there are any questions, if there are any queries, you can just drop that on the comment section, and would reach back to you on to help you out, or you can just send an email to the host, and they'll get back to me, and I'll reply the answers. I could just reply on the comment section if there are any questions. Thank you very much, and do have a nice day.